example is actually exactly the same as the previous example, except I'm asking a different question, which demands I use different laws in order to solve it. In the diagram below, M1 is 15 kilograms, M2 is 20 kilograms, M3 is 20 kilograms, and R is 0.5 meters. What's the acceleration of the objects? So we've actually done this example just previously, where we actually asked what the velocity would be if M3 had fallen about uh, 1 meter from its initial position. But in this case, we're asking what's the acceleration of all these objects. All right, so in order to do this, let's give ourselves a axis. Let's let this be the positive y direction, and this will be our tension T1, tension T2. All right, and let's write down Newton's laws for each one of these objects. All right, let's consider force diagram on M1. It's going to basically feel a force downward gravity force M1g. So for basically F net on 1, that says M1 times A, this is just going to be equal to the tension T1 minus the force of gravity M1g. Note the difference in signs because this is in the negative y direction, this is the positive y direction, is equal to that. Alright, so that fixes that one. F net on 3, this is the easier one still. This is going to be M1. Alright, so I should be careful. Let this be A1. M1A3 is equal to what? Now, again, the tension is positive T2 minus M3G. Alright, okay. Last one. Now, we have to consider the fact this is a string, and so basically if A1 goes up, then A3 goes down. So these two will be different by a sign. So if I let A equals A1, that means that A3 is equal to minus A. Alright, I'm going to use this in a second. So I can have one common acceleration. Last one, let's do this one. Now this one is a rotating object. So in this case, it's the torque net, which is the sum of the torques, which is what? Well, if I choose to be positive in this direction, that's the rotating direction, right? Then T1 will cause it to be positive. So T1 times R is the positive torque minus the negative torque, T2 times R is equal to what? Well, it's basically equal to I, where I is, times alpha of 2. Okay? All right. Now, because it's rotating this way, I've chosen my A to be positive this direction. That also means that alpha is equal to minus A over R. Okay, so what is I2? I2 is a solid disk. So this is going to be just simply 1/2 M2 R squared. All right, so let's just plug everything in first for the net torque. So this would be T1 times R minus T2 times R is equal to 1/2 I M2 R squared. Alpha is just going to be minus A over R. Okay, the R's will cancel there here. These R's will cancel all the other R's. And so you get T2 minus T1 minus T2 is equal to minus 1/2 M2A. Alright. Okay, so now what we'll do is going to solve T1 and T2, plug it in here. Right? So this term gives me something that looks like this. Okay? M1A, right, is equal to T1 minus M1G, which means that T1 is equal to M1G plus M1A. This term is going to give me something that looks like M1A, because it's A3, which is minus A, so it's a minus sign. It's equal to T2 minus M3G. So that means that T2 is equal to M3G. Whoops, this should be 3. M3G minus M3A. Okay? So almost they look the same, except that there's a difference in sign. And that difference in sign comes from the fact that like one's going to accelerate downward, one accelerates upward. Right? And that counts for all that. Alright, so now let's take this and plug it into this equation here. Okay, so let's write down T1 first. So this term gives me M1G minus M1A minus T2 is going to be M3G minus a minus a plus. I screwed this up, so this one is a plus sign, plus M3A is equal to minus 1/2 M2A. Alright? Okay, so now we can solve for all the M's and all the G's and all the A's. So let's solve for the A's. So plug all the A's on one side. This is going to be equal to, so this is going to be equal to what? Well, let's see, this is going to be M1 is 15 plus M2 on this side, put the minus sign and everything. M2 is going to be 20. And then plus again, 1/2 times 20. A is equal to what? M1 is going to be 15 minus M3 is going to be 20. G, all right. So again, we know what this is. This thing, well, this thing's a little bit different. We should just calculate that carefully. So bring our trusty calculator here. This is going to be 5 times 9.8. 5 times 9.8. This is a 49. It's equal to 15 plus 20 plus 0.5 times 20 again. That's 45 minus 49 minus 45A, which implies A is equal to 49 divided by 45 to 1.1 meters per second squared. Okay, that was a little involved, but it wasn't too hard. Once you set everything up, you can just go ahead and just solve it.